Hi, and welcome to the next installment of Excel for Introductory Statistics. In this video, I want to talk about the standard deviation. I'm not going to talk about what it means or the definition. We did that in class. What I want to focus on here is calculating the standard deviation. And you'll see over here on the right-hand side in the blue box, I have two formulas for the standard deviation. Now, this is the first time in this course that we've seen a different formula. They're similar, but they're slightly different. A different formula for the sample statistic versus the population parameter. The formula on the left is the sample standard deviation. So let's put sample here. And on the right, sigma, that's a lowercase Greek letter sigma. This is the population standard deviation. Now, generally, the one you're going to be calculating is the sample statistic, the sample standard deviation. In this case, we have a data set that shows the responses by a sample of students that were asked the question, how many tacos did you eat last week? Now, the key word there is sample. That tells us we're using the sample standard deviation. So how many tacos did you eat last week? We asked 10 people, and these are the responses. The first person ate 12 tacos last week, the next person 3, the next person 0 tacos, and so on. So let's calculate the standard deviation and round it to the nearest tenth. So round it to 1 decimal place. And we'll put it here in this yellow cell. You can put it anywhere you want, but we'll put it in that yellow cell. Now I'm going to do this two different ways. First, we're going to calculate this manually using a calculator. So I'm going to be using the TI-84 graphing calculator, a really common calculator. And then we'll use Excel, and we'll compare these two methods. Okay, so, and let's see if I could get both of these on the screen at one time. Okay, looks good. And I'm gonna write the formula over here on the left so we have it in front of us visually. So that's the square root of the sum of the squared deviations from the mean. Oop, that square is in the wrong place. That should be x bar squared divided by n minus 1, the approximate average of the squared deviations from mean. If it was the population version is the exact average. Okay, so the first thing you'll see is, well, there's a number of steps here. We have to do a subtraction, then we've got a square, then we've got a addition, that's a sum, then we've got a division, then we've got a square root. So there's multiple steps in this calculation, and you'll see that each of the first steps, the subtraction, if we're following order of operations, parentheses first, the subtraction involves subtracting the mean. So we can't find the standard deviation without first finding the mean. So let's calculate the mean. Well, we're going to have to add the numbers up and divide by 10. There's 10 numbers in our data set, so there's 10 numbers, add them up, divide by 10. So let's go over here to the calculator, turn it on. So we've got a 12 plus a 3 plus a 0 plus, you can leave the zeros out, that's fine either way, plus 5 plus 6 plus 5 plus 1 plus 0 plus 8 plus 6. So that's 46. And we have to divide that by 10. So let's write that here. 46 divided by 10, which is going to be a mean of 4.6. We can do it here on the calculator as well. Okay, so the mean response to this survey was 4.6 tacos last week. You know, the people I survey, they eat tacos pretty often, as do I. Okay, so now that we have this, let's calculate the standard deviation. So we're going to have to take each x value. So these are our x values. These are our x values. X values are the data values. We're going to have to take each one of those and subtract the mean. So we're going to have to do 12 minus 4.6 3 minus 4.6, and so on. We're going to have to take each value and subtract the mean. 12 minus 4.6 equals 7.4. 3 minus 4.6 equals negative 1.6. And I'm just gonna I'm not gonna go over to the calculator and do it for every step. It's gonna take, this video would be 30 minutes long if I did that. So I'm just gonna write down the answers. 0 minus 4.6 is a negative 4.6. 5 minus 4.6 is a 0.4, and so on. Let me just give you 1.4, 0.4, negative 3.6. Let's make this a little bit smaller to get some room. Negative 4.6, 3.4, and 1.4. So I've taken each x value and subtracted the mean. Now I got to square each one of those numbers. So x minus the mean squared. Next is that second power, order of operations. So we'll take 7.4 and raise that to the second power. So we get 54.76. And if we square negative 1.6, that's 2.56. And I'll give you the rest of the calculations because I don't want to take too much time. Negative 4.6 squared is 21.16. Then we've got a 0.16, a 1.96, a 0.16, negative 3.6 squared, 12.96, 21.16. I've done these calculations ahead of time, just for the interest of this video not being too long. Okay, so now we've done the subtraction of each x value minus the mean. We've taken each of those 10 numbers and squared them. Now we've got to add them up. I also have to take these 10 numbers and add them up. So 54.76 plus 2.56 plus 21.16 and so on. Now again, I've prepared this ahead of time. That's 128.4. Then we have to divide by n minus 1. So 120, well, let's put the formula in here. The sum of x minus x bar squared divided by n minus 1. So that's 128.4 divided by 9. And that's going to be a repeating decimal, 14.2 with the 6 repeating. That's what I got when I divided by 9. And then finally, we have to take the square root. And that's the last step in the formula, x minus x bar squared divided by n minus 1. So that's going to be the square root of 14.2 with the 6 repeating. And if we round that to, maybe we'll use 5 decimal places. We always want to use more than we need. Oh, actually, no, this is the last calculation. So let's just say that's I got 3.7771. So we'll round that to 1 decimal place, 3.8. Okay, so you can see this is a very small set, 10 numbers, so we get a standard deviation of 3.8. Now, what I want to do is show you how to do this on Excel. So our Excel function for the sample standard deviation is equal STDEV, that's standard deviation, dot S. The dot S is telling Excel, I want the sample version, not the population version. Remember, they're going to be slightly different numbers. because in the sample version, we're dividing by n minus 1. In the population version, we're dividing by n. And our in parentheses is the location of the data. So that's going to be A1 through A10. Okay, so here is the Excel version, or the Excel formula, equal stdev.s parentheses, and you could either type in A1 colon A10 or use the mouse to highlight those 10 numbers. And there's the same 3.7771. And we could use Excel to quickly round that to the number of decimal places that the directions are telling us to, which is 1. So just a couple of seconds. You saw that the calculations for, again, a very small data set took quite some time. Now, you may be saying, oh, I've taken a stats course before, maybe in high school, and we used the graphing calculator, and we didn't have to do everything by hand. The calculator has the built-in formulas. And yeah, that is true. You could have somewhat easily done this on the graphing calculator. So let's clear this. There's a stat function here. So you could have gone into stat and edit and typed in these numbers. So you could type in the 12, the 3, the 0, let's see, 5, 6, 5 again, a 1, a 0, an 8, and a 6. So now I have those 10 numbers. Do I have them all? Let's see, did I make a mistake? Let's just double check to make sure they're all there. 12, 3, 0, 5, 6, 5, 1. Oop, forgot the 0. 0, 8, and 6. Okay, so I have in list, this is L1 is list 1. So I have those 10 numbers typed in. I could go back to the stat menu and now go to calculate one variable statistics. And there's our standard deviation, 3.777124. It's the same one. All right, so we could do it that way as well. Okay, but that involves typing each number individually into the calculator. So if you think the graphing calculator is a viable or a good option, that's fine. Let's go over to sheet 2 and do the same thing. Calculate the standard deviation. Well, now on sheet 2, if we want to calculate the standard deviation of this set of 300 numbers, well, on the graphing calculator, we would have to go in and maybe go over to list number 2, and now you would have to type in manually these 300 numbers, which is something you definitely don't want to do. One, it's very time consuming, and two, with over 1,000 keystrokes, you're going to have to hit the buttons on the calculator over 1,000 times. It's very easy to make a mistake without even noticing. Okay, so as I've said in the past, learning how to do statistics on the graphing calculator is useless. Because in real life, in practice, we're not calculating sample statistics for 10 numbers, right? We're calculating sample statistics for hundreds, maybe thousands, tens of thousands, over 1 million numbers. You may be working in finance or economics, business. You might be working in biostatistics where you may have, 250,000 values, gene expression values or something like this, where it becomes logistically impossible to type them all into the calculator. Whereas on Excel, let me go through the steps one more time. stdev.s parentheses location of data. Okay, so if we want the standard deviation of this data set equal stdev.s parentheses, I'm going to use the mouse to just highlight the locations. It's A1 to J30, enter. All right, and that's it. There's the sample standard deviation. It took me longer to write the words sample standard deviation than it took to actually calculate it. Okay, so whether it's 10 numbers, 300 numbers, as you just saw, 3,000 numbers, 100,000 numbers, it takes the same amount of time on Excel. All right, that's it for this video. I hope this was helpful.